Where are you guys at? Okay. So I'm just gonna continue off where we last stopped. Sorry for the I think I'll just rather record them pre-hand and upload them from now on, and every day there would be like an episode. Um, so we're gonna get started with web black box recon. So to recap, we last time we took web passive recon, where we never actually touched the server, we never actually did anything, and we learned that we learned about a lot of stuff. I just want to recap a few things. There are a couple tools that I um, recently just learned about. Um, you have things like, to be technically, that is, you have things like WhatWeb. WhatWeb is supposed to be a fingerprinter, a web fingerprinter. So you run it and then you run the URL. Now, see, there are aggressive scans, but we want to go with the passive. So the one is stealthy, makes one HTTP request per target, and also follows redirect. So literally just one HTTP request, and it is as stealthy as you could be. However, less information. So we're just gonna do FBI.gov just because we can. Uh, and see, you get a lot of information right off the bat. You get, okay, so it's running behind Cloudflare, and you get the cookies. You get the cookies that are going. You know the disadvantages of living in a house with multiple people. But okay, so as I said right off the bat, you get, okay. So you realize something, that 301 basically means moved permanently. We got redirected from HTTP to the HTTPS page. That's one thing. Another thing, we got a lot of information. Like, here you go, the IP of the server. However, it's Cloudflare. We got that they're using Castle CMS. I don't know what that is, but a CMS is basically a kind of like an easier way of building a website, a content manager system, I think is what it stands for. You get to see a lot of things. Here, the title of the page, welcome to FBI.gov. We get a bunch of their uncommon headers. We get their Google looks like they're using Google Analytics, and you get their Google Analytics code. And so you get a lot of things from WhatWeb. It's a fingerprinter. We can go aggressive, but for now, I don't really want to go aggressive because you can't really black box test against sites that you don't have permission to. WAFWolf is also a. It's supposed to. Oh, there's a setup. Oh God, why? I think we could just run it. No, nothing should happen. Nope. Looks like we gotta set it up. So WAFWolf is basically supposed to be a firewall fingerprinter. So you run it, and then you're supposed to type in the website. So if we type https fbi.gov, it should test a couple of times, and then it should tell us that the site is behind Cloudflare. Immediately, it should tell us. It's basically if you want to identify if a site is behind a firewall, web firewall. So HillaryClinton.com. I think this should, okay. It said no firewall detected. Um, I think they have options. You could go aggressive. Yeah, you could go headers file. You could be verbose and find all, and then HTTPS Hillary Clinton. However, verbose is kind of gonna be, it's gonna be a lot of output. thanks to how how any program being verbose works. Um, I think live streaming was a bad idea because we're already like 16 minutes in, and there's a lot of things. I think I'll trim all the stuff later if I ever feel like it. Uh, um, Sorry about that. And we're back, I guess. Right. So, black box testing for web Recon. Recon, it includes vulnerability scanning. However, it doesn't include the exploitation part, because remember, we're just doing recon. We're not exactly attacking anything. We just want to know what exactly is going on and what exactly we could do. So for command line scanners, web scanners are there's a lot. There are a lot of web scanners. It pretty much depends on your preference. If you search GitHub for web vulnerability scanner, you're going to end up with more than like 100 tools in your hands, and you can use them all. You could use a few of them. You could even, if you're feeling lucky, you could go and buy some tools from like the companies that make tools like Nessus. Nessus is a paid tool. Uh, or you could use open source alternatives for just for pen testing purposes. And an example of that most popular command line web scanner is Nikto. It's called Nikto. Um, Now for this, I'm going to be using a VM called DWVA, which stands for DVWA, which stands for Damn Vulnerable Web Application. It's a web application that's vulnerable on purpose, because to allow you to test tools and learn about pen testing. So it's actually a Docker image. So okay, we are gonna have a problem, aren't we? So I'm gonna launch it up. You could follow the same command that I'm gonna do right now. It uses Docker, so I'm assuming you have Docker, but install Docker yourself. And here we go. We're gonna run it. This is actually the command, and we're gonna say the password is 123 123. We're just gonna make it like this for now. It's gonna run Docker, and there we go. Now, if I curl localhost empty reply from server. All right, I'm just gonna go set it up. I think I'm gonna go for a full screen display so that you guys could see what's going on. Disable the time, disable terminal. Move this here. We're gonna go localhost. Here we go. Here we are. It's just gonna say setup. We're gonna clear and reset the database. Please log in. Let's go to the login page. Now I think it is admin and password. And we're gonna go to security. It's on impossible and secure against all vulnerabilities. So we're gonna go on low, which is practically no security measures whatsoever. We're gonna submit. It should be like this. PHP IDS is okay. We don't need to worry. This is a web application firewall, and it's I would enable it later on just so I could show you an example of what a firewall would see if you're scanning it for attacks. So here we go. We have DWVA set up, and so now we're gonna go and we're gonna do our normal recon scans that we usually do. So actually we don't really need to do that because it's a web server, so we're just gonna attack it with Blackbox instantly. So what we're gonna do is that we're gonna do Nikto host localhost, and that should be it. And it should just go instantly directly. And as you can see, we're already getting stuff like robots.txt contains one entry. It found the config in directory. It found the document docs in the directory. It found a README file which leads that Apache default file installed, and then admin login found. It's gonna say server. It even told us the server. We know that it's Apache running on in Ubuntu. Return a non-forbidden. Blah blah blah. Should be good. All right. So it didn't tell us much, right? Because usually Nikto is not the kind of aggressive scanner. And besides, because we need to log in, we didn't log in. We don't have access to any of these things unless we supply some credentials for it to log in. So what we're gonna do is that we could attack you could brute force the main page. However, brute force we don't really like to do that. So hmm. Trying to understand how would you usually go using a web scanner against a website that, but it requires a login to access all the stuff. You need to log in to take a look at all this stuff, all the vulnerabilities. So all right. Wow, okay, so we're gonna have to look at the configuration. Tuning, do some scan tuning. Use H for full output, okay. J, blah blah blah, format evasion, display, ask. I don't even think you could use credentials with Nikto with DW. I just need to understand how are you supposed to get get around the password. Nikto update host DWVA. Oh, I guess this is old because we don't have the slash DVWA anymore. Oh wait, we do. Does it work though? No, it doesn't work. It's this is not gonna give us anything. Uh-huh, I see. Okay, whatever. I think I'll crop that out. I'll definitely have to crop that out. Okay, so if I'm gonna spend all day here showing you stuff, we'll never get around. So, another common tool is called Zap. Now, I'm gonna run it. Zap is provided by OWASP, the same people who have the OWASP top 10, which are the top 10 vulnerabilities for web stuff. So this is a really good scanner. I actually really do like this scanner. No. And we're just gonna get started, and we're gonna say local host, and it's gonna attack. And as you can see, it's immediately just gonna go and spider through everything, and then it's gonna actively scan everything. It's gonna go super fast. Well, that's because we're on localhost. There should be no vulnerabilities. We should go to alerts, directory browsing. See, it already told us that it could browse for directories. And I think the spiders, I think the scanner is done. Yeah, that was actually pretty fast. So what we need to do is that we need to give it the freaking concurrent scan threads. I usually like to make this a lot more. Handle anti-CSRF tokens experimental functionality. HTTP sessions. I'm really just trying to nope. I'm really just finding a way to provide credentials. So I think the way you could do it is adding authentication. Is setting your browser to proxy through Zap. Huh. Advanced network settings. Okay, so here we're gonna go. I think that's literally the only way how to do it. Local proxy, local host 8080. Set your browser above. Yeah, I think that's the only way you have to do it. So we need to go to Chrome, and we need to go to Chrome settings. Hopefully there's nothing here that like, okay, my email, GG all this, GG proxy. Okay, disable. Okay, so betternet was controlling our proxy settings. Hey, can I have my proxy settings back, please? Wow, and then it just doesn't give me my proxy settings. Are you serious? Network, change proxy settings. Wow, I could have done it from here. That is just sad. That is sad. We're gonna go localhost, and we're gonna go 8080, or is it 80? Yeah, it's gonna be 8080, and we are gonna apply. There is so much wrong with this stream today. Set your browser, and we're gonna go forced browse. And I think if we go localhost, it should bring up something here. Nothing. Really? Alright, you know what? Screw it. We'll get to this in web exploitation. This is not really web exploitation right now. Recon, Blackbox, as I said, just to summarize everything, you literally, all you have to do is just run the vuln scanners. We wanted to learn Blackbox Recon, right? Not really necessarily a not necessarily web recon black box, because the only thing with web recon with web black box recon is that you literally just run the vuln scanners. And so what we're gonna do here is we're gonna go into my hacking folder. Jeez. Do I have any other tools? No, I have W3F. We can try running that. However, I have no hopes in it working. Yeah, it is. It's not gonna work. Which CDN? We could try all this against our local host, but we really don't want. And since, so I'm gonna docker stop, docker show. Freaking hell, is it that bad to just freaking list? Docker info. None. Okay. Docker stop lobby. Seriously. Manage containers. Docker container. Docker container ls. Wow, that was that hard, right? You couldn't just freaking tell me. Docker stop. The name is Jolly Dubinsky. I have an even better example. I have my Metasploitable VM, which is way better. Should be way better. Right, okay. Metasploitable is basically, I need to change my proxy settings since I turned off Zap. I need to disable this. Hopefully nothing happens once I disable. Uh, we're gonna move on. We're gonna move on to the so Nmap, as I explained Nmap last time, you could do a lot of passive recon with Nmap is actually not even passive at all. And the moment you start touching Nmap, that's Blackbox. But I think I wanted to touch is on Nmap a what do you call it? You know what? How about we just do a whole restart on this goddamn thing? Okay, I'm at this because this stream has been a disaster ever since I started. Because my track of mind is completely off today. I'm really sorry, guys. Um, so just to fully like for a too long didn't read part, if because I'm probably gonna crop out everything in the beginning for those of you who are gonna come watching. So um, scanners basically for web pen testing, that is web recon, that is black box. You're gonna run vulnerability scanners, and how do vulnerability scanners work? You're literally just gonna run any vulnerability scanner you find at a target and run it. And since I don't have a proper target, because DVWA is not exactly uh, a what do you call it? Uh, it's not a perfect target. I will say it's not exactly built for automated scanning tools. You have to kind of throw yourself at it, but we'll get to that. We'll get to that. So right now, I want to just teach you Nmap scripts. So actually, I want to update Nmap because they just released a brand new. This command updates brew itself. Does not take. Use brew upgrade. Upgrade Nmap. Because Nmap, they just released a brand new update with a bunch of new skins. Not skins, jeez. With a bunch of new scripts. So I wanted to test those out. So Nmap scripts are basically, yeah, yes, we're getting the new version. Nmap scripts are practically uh, things that get more information. So if I go nmap osx script location, I think you could just, they're called NCEs. So if I just find slash grep NCE, I think I should find out dot NCE. Seriously, I think it's in the slash user local share nmap. Yeah, there we go. Scripts. Uh, scripts. And you'll see that there are a lot of scripts. What we could do with these is that you basically, you can't really tell Nmap to use all the scripts automatically. You can't really do that. You have to use the scripts depending on what you're aiming for. So in the case of, let's use scanme.nmap.org, right? So scanme.nmap.org. We need sudo, we need ss, sv, pn, v, t5. I just want to get over with this. T5. Yeah, that's it. I don't even want I don't want even want sv because we don't really care. I just want the goddamn port scan. Right, so here's what we're gonna do. So it's gonna run the scan, which is like any other normal nmap scan, which according to the assignments that I had put in the Discord server, if you were following the Discord server, you should have completed these. You should know how to use nmap by now, basically. It's going really slow for some reason. That is odd. It is usually not this slow. Huh. Is scan me even up? Scan me, go ahead and scan me. Ah, port 80. Okay, so we know port 80 is up. Okay, I'm just gonna skip this whole part because apparently something's wrong. Port 80 is open, HTTP. We got that down. So here's what we're gonna do. You want to run a script, so you're gonna say script equals, and then we need to pick out one of these scripts that we just saw. So to do this, I'm gonna open a brand new terminal. And I'm gonna go cd share. Actually, I want to take this command and put this command here, and then use this terminal to kind of like use this terminal for the scripts. So we're gonna do ls and pipe to grep and HTTP, and here you go. We get all these HTTP ones. So we're gonna say, okay, let's look at these. What is there? Let's look for HTTP enum. So okay, use HTTP enum and run. So it's gonna script scanning and it's initializing the NCE and it's running the script now as we speak. And it's gonna take a lot longer, obviously, but it should come back with some extra information. Now, you could scan for a lot of things. You could scan for SQL injection. You could use Nmap to scan for SQL injection. You could scan for shell shock. You could scan for if any passwords are exposed. You could scan for proxies, for open redirects. All of these are vulnerabilities. We'll get to that later. But do notice that it takes a reasonably much more amount of time. Security headers, server headers, slow LoRa's for slow HTTP to us, um, user agent tester, trace route, trace, the title of the page. All of these, some of these are very basic stuff, and some of these are actually useful, like WordPress users, WordPress brute force, WAF detect. WAF stands for WAF, Web Application Firewall. ASP.NET debugger, and it's a lot. There's HTTP brute force for brute forcing HTTP directories, I think. Cross domain policy, CSRF, date, all of this stuff. See, you could use this stuff to your will. Okay, use it as much as you want. I don't know why this is taking a whole lot of time, but I think my VMware is up. So we're gonna go MSF admin to log in, and we are in. It's that to open. Does this even have an HTTP server? Does can I like go of my mouse? Okay. grep 80. Oh, so it does have so we're gonna go ifconfig really quickly. I just want to get the IP address of this thing, and we're gonna release my mouse. Please let go of my mouse. Can I have my mouse back? Jeez. Control command. Okay, there we go. So we're gonna leave this running. Can I copy this? No, okay, because I forgot there is no mouse. Okay. This is taking a long time. Okay. So what would you usually do in a black box recon? So we're given an IP. Here you go. We have this IP. So usually what we're gonna do is that we're gonna port scan this IP, right? Nmap. We're gonna go nmap ss sv. pn t5 for maximum speed, and we don't really care about the OS. I already know it's a Linux installation, but you just want to port scan. So 2.35129, we're gonna run it, and that is a lot of ports. That is a lot of ports. Now we don't really want to run surface scans, but we notice that port 80 is one of those ports. So we specify port 80 to be exact, and we tell it, okay, we want to focus on the web port. So it's going. And here you go. Okay, so we know it's Apache, and it's open. It's Apache, and it's running on Ubuntu. This is an Ubuntu machine, and it has the AV enabled. So what we're gonna do is that we're gonna go back. We're gonna go and we're gonna do okay. So we know Apache is enabled, right? So we're gonna go up here. We're gonna say, all right, let's actually just use something that's normal. We're just gonna go HTTP. The one that we used last time. What was it? Let's actually grep for DAV. There should be something on DAV here. Oh, HTTP web DAV scan. So we're gonna take this and we're gonna go, okay, script equals web DAV scan, and we're gonna run it, and it's gonna scan one service, and then it should initiate the NCE soon enough. Wow, the HTTP server. Wait, that is not what I wanted. Oh, okay, so that's all this. That's all what this NCE does. Literally, that's literally it. It just reported to us. It confirmed that it is Ubuntu and DAV2. So what we're gonna do is actually you could do. We're gonna go HTTP WAF detect. Let's say right. So it's gonna run that. What the hell? It keeps sending over HTTP sender. Why does it keep doing that? Why is it not taking the script? Right then, we have a problem. Why do we always have to have a problem like this, guys? Why are you people always the ones doing this to me? Okay, let's actually try now. .nce. I think the SV is kind of what's ruining everything, and the T5, the intense speed, is kind of ruining a lot of things. Uh, SC for script scan. That's it. Something is severely wrong here. I need to know why. We're gonna remove the speed. I'm gonna remove verbosity. What the heck? It's almost as if it just ignores the whole the script part. What the heck? Why is Mac so broken? Why is everything on Mac broken to goddamn? Uh let's see. Script scan. Okay. Alright, if we do SC, it should do script default. If I do script everything, okay. So if we do SC, it should run a set of scripts. Yeah, it should run a default script. So HTTP title metasploitable to Linux. However, I don't see why it's refusing to run any other script. So like if you do script equals HTTP enum. Why did it work now? Okay, HTTP enum, and it basically went, okay, it showed us a bunch of stuff. It says possible information file, PHP my admin, doc, and icons and index. It gave us a bunch of information. So that means that if you go HTTP WAF scan, was it? No, right? See, the problem is cd/share/nmap. Wait, what's the working directory here? Oh, cd/user/local/share/nmap/scripts. So we're gonna go with another HTTP one. So we're gonna go ls grep HTTP. We're gonna go for the let's see, HTTP. I'm sure there was something here that we could have used. HTTP errors, let's say. So we're gonna go HTTP errors. Okay, so now it's working. I don't know. Found the following error pages, and it was looking for DVWA, but we didn't never found it. So we know that this HTTP port has DAV enabled, right? So we're gonna search DAV, and we're gonna see that they have a web DAV scan. So we're gonna go script web DAV scan. Now see, why does that just like provide? Why does that just do nothing at all? Because if we provide a script that doesn't exist, it says, okay, you know, uh, I couldn't find the script you're looking for. However, if we give webdav, it just kind of dies. Okay, it must be broken because I'm running on Mac. Okay, don't worry. Usually you'd be running this on Kali. It would be much more stable. I never got the chance to set up my Kali, so that's just the only problem I had. Uh, Let me just see if anyone sent anything. No one said anything. No one asked any questions. All right. Um, Today's a really sloppy lesson. What else? What other ports did we find? We found port a. We found port. Let's see. I'm gonna remove all this. We found port 21 enabled. I'm thinking, right? Oh wait, that's the wrong target. No. Where? What is our target again? Where is our IP? Okay, there we go. Uh, port 21 was open, if I recall correctly. And so what we're going to do is, yeah, port 21, which is FTP, and you could go script equals, and you could go, ls, and then grep for FTP. Let's look for FTP, and we're going to say, okay, so they have an FTP here. Oh, we could check if this is backdoored, So you're going to do this, and you're going to say, put this here, and it's going to say vulnerable. It's going to say, wow, this port is actually vulnerable. And there is a backdoor on this, and it actually did, it exploited it, and it got a root shell. Uh, so Nmap is pretty cool. You could, there's scripts for everything. If we just run a quick scan in Nmap, just one more time, I just want the full range of IPs here. If we run this again without specifying a port or a script, actually, I just really quickly, and then open, this will basically show us only the open ports. Let's say you have port 445, which is SMB. So if you ls and then if you grep SMB, you'll see, okay, we could check if it's vulnerable against this one exploit. So then we could nmap. You could nmap the same target, and then we say, okay, script equals this, and port 445. Now, okay, because the script is kind of broken, it doesn't really work. I think it's just a problem in the nmap help. Script update DB. Yeah, I think we have to run that. Script update DB. Script database updated successfully. Still, we're getting nowhere. You know what? I think it's also this. I think it's also the. And then port 445. Okay, so again, as I said, it's just because I'm kind of it's broken for me because I think it's because of Mac. But let's say if you do SMB enum users, let's say, or SMB enum in general, I'm pretty sure there is SMB enum. I think if you just do SMB enum, no, wow, really nothing. Wow, you could do SMB ls. Seriously, none of the SMB ones are gonna work. None of them. Not even system info. Are you freaking serious? Oh, I think it's the SC in the beginning. If we remove this and I say I literally just want to script scan, nothing. That is just weird. Okay. If you scroll back up, okay, we can't scroll back up, but that is introduction to Nmap script scans. You basically search up a port, uh, ls and grep for the Nmap script. Sometimes there are Nmap scripts on the internet that you could download and use. You should learn the NCE scripting language so you can build your own Nmap scripts. I myself I haven't learned it, but it is useful in some cases. Another thing to note about, so that is it for now. That is, so right now you guys know Nmap, and since we're learning black box testing, I should probably go over all the options that you see in Nmap here, so I could give you guys an example of complex Nmap. So let's go through them one by one, okay? I'm just gonna pipe this to more. I know a certain person who won't like me piping to more, but we could go. Oh, that actually didn't help at all. Uh, it literally just didn't help. Okay, okay. It's just I don't really like looking at huge amounts of text. But can I zoom in? Oh wow, I can. Okay, Mac, everyone, Mac. Uh, Let me just. Does this affect my other terminals? No, it doesn't. Wow. Okay, that's actually pretty cool. Um, IL is input file name, input from list of host network. So you could have a file of targets and you want Nmap to scan through those targets repeatedly. Let's say you get a list from the company you work at, a list of all the domains and all the IP ranges you're allowed to scan. You take them and you take it and you put it. Uh, Number of hosts, choose random targets. Oh, random targets from the file. You could exclude some hosts and you could exclude list from file. Okay, just ignore that. Uh, an SL scan. It's not actually a scan. It just lists the targets that you're gonna scan. So let me have a smaller terminal here. Uh, Let me actually make this a little bit bigger. All right. So if I do So in Nmap, you can provide ranges. You guys should go read up on subnets, but a /24 subnet is basically from point one. It basically changes the last number from whatever it is from 0 all the way to 255, which is a classic subnet for a normal home network. So if I do Nmap and then I do SL, it's literally just gonna. I don't think it shouldn't scan. Okay, so a good thing to do is that you should put your arguments before the target. It should simply just list the targets. I don't know why it's actually attempting to scan anything. Yeah, okay. So it was just doing reverse DNS. Okay, you could tell it to go faster. It should literally all it should do is just output the targets it is gonna scan. I'm gonna actually wait for it to finish, and you see it literally just outputs the targets that it's gonna scan from, as I said, from 0 all the way, the last number, all the way to 255. That is /24. So right now, so SN is ping scan. This is usually if you want to know if who are the hosts that are alive on a network. You don't really want to what do you call it, port scan any of them. You just want to ping scan. It's like pinging every single computer. So if I do that on my home network, but I change it to a ping scan, it should take a while. And there you go. So I got the hosts that are up. Host is up. This IP 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 is up. 6 hosts are up on my home network. And another one is PN, because usually what Nmap, what it likes to do, if you add verbose, you'll see in the beginning, it is okay. Actually, you should remove the V, remove the SN, and put SS, and then like as if we're gonna port scan my entire subnet. If I'm gonna port scan my entire subnet, and it is gonna sudo, I'm just gonna sudo this. You should notice that Nmap, it first, Nmap will not scan the entire subnet exactly. It's not going to scan 255 hosts. It's going to ping them first, see which ones are alive, and then scan the ones that it sees that are alive to save time. Why would you scan a dead host? So the PN flag at the top over here, the -PN, treat all hosts as online. Skip host discovery. So don't ping the hosts to see who's alive. Treat every host that in the list as alive. Scan them even though if they don't respond. This is usually good for systems that evade, that don't really respond to pings. There are systems that don't respond to pings, and Nmap will think that they're dead when they actually aren't dead. They're just not responding to pings. I don't know how to bring this back. I want to bring this on top of that. Oh, this goodbye you. No, don't full screen. I just want to. Seriously, I can't just access my other window. Seriously, Mac? Oh, I could do that. Oh, I didn't know. Okay. Um, so PN is going to treat all hosts as online, and it's not going to scan the network for them. Now you see BS or discovery to given ports. This is new. I have not seen, or actually I haven't seen this before. TCP, SYN-ACK, UDP, or SCT discover to put different to given ports. I have no idea what that is. ISMP echo, timestamp, and netmask request discovery probes. You guys don't really need these two. IP protocol ping, you also don't need this. Never do DNS resolution or R. Always resolve, and the default is sometimes. So usually if I have a computer on the network, most devices on a network have DNS names. So for example, I'm going to scan my network with a simple ping scan, and I'm going to tell it to always resolve DNS, and we're going to go with it, and we're going to wait for it to come back. So I don't really have any IP addresses. I don't have any. Sorry, I don't have any hosts on my network with DNS names. But for example, if you scan something like Google's DNS, right? 8.8.8.8. See. Oh, see, and see, this is a real life example. Host seems down. It's blocking our ping probes. Try PN. See, so 8.8.8 doesn't respond to pings. So I need to say treat it as alive. And as you can see, it changed. It did a DNS scan, and it said Google Public DNS. This is the name. This is the name of this IP, and that is useful for finding interesting machine names on a given network. I could do .1/24, and we're just gonna ping scan the entire actual 8.8.8.8 subnet. Let's see if any of them. Well, oh, okay, because we added the PN, so it thinks every single one of them is alive. However, you'll notice that the only one that actually responded is 8.8.8.8. That's weird. I thought 8.8.8.4 should respond. Isn't that also one of Google's DNS servers? The 8.8.8.4 host is up. All right. Okay, doesn't matter. So basically resolves IPs to using DNS. Now these three, you could either specify a specific DNS server to use. You could use the OS's DNS resolver, your own system's DNS resolver, or trace route is trace where the packets went, like each host that your packets went. So if I let's say I could do this. So I could do trace route and then just do a simple ping scan, and I'm gonna go to google.com, right? It's just gonna ping Google, but I just want to know where my packet went before it reached Google. And so it's gonna go through that, and it's gonna say, okay, so first it went to my router, then it went to this IP, which is some ISP gateway, and then another ISP gateway. My packet went through all these gateways before actually reaching my Google, which is at this IP. I think if I ping google.com, I should get the same IP. Yep, same IP. 216.258.207. So these are just the machines between me and Google that my packet had to go through. And this is usually good on a network for debugging where routers are if there are multiple routers on a given network. Another thing is scan techniques. Now, this is where things start to get interesting. The default scan technique is the TCP SYN SYN-ACK. Now, if you know how TCP handshakes work, it is if you want to connect to a certain port using TCP, you the client will send a TCP SYN packet, and then the server should respond with a TCP ACK packet, and then you will send a SYN ACK packet. So what happens is if I open Wireshark so that I could sorry for the noise. If I open Wireshark so I could debug what's going on, I'm actually going to open up Wireshark, and I'm going to say, I have no idea which one of these is the one that we should be looking at. I should be looking at the Wi-Fi. You don't have permission to capture on that device. Alright, I forgot we have to run Wireshark or sudo, which kind of sucks. It's going to give me a warning now. It's going to say, oh, you're running as sudo. Oh, okay, actually it didn't. So, oops, that is the wrong one. Yeah, here you go. So Wi-Fi, okay, you're gonna see all this stuff. You're gonna see all these packets. This is usually because my machine is continuously sending packets to the YouTube servers because I'm live streaming. So, however, I'm just gonna make the TCP dot port is equal to 80. We're gonna limit it to let's say FTP traffic. So here's what we're gonna do. Actually, I'm gonna bring up my Wireshark. I don't want it to go away, and we're gonna bring up my Nmap. And oh no, wait, this is actually Nmap is not running here. We need a new one. So we're gonna minimize this, and we're gonna say, uh, let's go to my VM. Actually, we're gonna just hit my router, and I'm gonna say I want to scan using SS, which is the TCP SYN, and we're gonna say port 21, and then we're gonna press enter, and it's gonna ask me for sudo because yeah, we're gonna type in sudo, and immediately here you should see a bunch of packets show up. So here, what happened? I sent my computer sent a SYN packet to the router, but then the router responded with an RST, a reset, which meant that this port is not open. However, look what happens when I hit port 80 on my router. I know that my router has port 80 open because I just do, for the web interface for the router. So I'm gonna bring this up. We're gonna clear this. And Nmap told me it's closed. And I'm gonna say port 80, and it's gonna be a, well, technically it still looks weird. Oh wait, port 80 is actually closed on my router. I think it's port 8080. I think it is port 8080. And see, the router didn't even respond this time to our ping request. We're gonna add PN, and wow, it's still closed. Okay, okay. IP dot. I'm gonna do so that I'm only looking for 192.168.0.1. I'm only looking for the packets that have been going to my router, and IP dot proto equals TCP. I'm only looking for TCP packets. Can I just have TCP? Really? I can't. Okay, okay, okay. Whatever you say. Uh, that is so weird. We actually got a SYN packet from port 80. Uh, no, no, don't launch WhatsApp, please. Please stop doing that. Okay, so we're gonna go to Wireshark, and I'm doing this just so you guys could have a good example. We're actually gonna run. I'm gonna show you what happens when you actually run a fully blown port scan on a target, right? So we're just doing an SS. Look what happens. You see all these packets that literally came out of nowhere, and then Nmap should report to us that it only found one, which is 53. Now, see what's going on. My computer is sending out packets to this. This is the destination port. As you can see, Nmap is spewing out packets to the 1,000 common ports it knows. It's just repeatedly just spamming out SYN packets to each one of those ports. Now, let's see, you want to see what would the result be on scanme.nmap.org. How would it look? So here's what we're going to do. God damn it, I keep forgetting how to bring up my freaking terminal. And anyone say anything? Nope. So I'm going to ping scanme.nmap.org because I need to know the IP. We're going to say I only want the packets that are going towards this IP. And see, it just picked it up right now when I pinged it. And here's what we're going to do. So I'm going to run the same thing, however, on scanme, scanme.nmap.org, and we are going to do PN to assume that it's alive. And as you can see, it's just sending out those packets. It's repeatedly just sending out those packets. See, even for the same port, Nmap sent the same packet a SYN packet 4 times. This is something that Nmap does to make sure that a port is dead and it didn't just just not receive a response. So we know that 22 port 22 and port 80 are open. So we're gonna go to when Nmap sent the port 22. Port 22. It should be at the very top here somewhere. SYN. See, I sent to port 22 a SYN packet. So we're gonna follow the TCP stream. The server responded with a SYN ACK, not a reset packet. The server responded with a SYN ACK, which the server responded with a SYN ACK that basically the server responded with a SYN ACK that showed us that this packet is alive. So the server responded with, okay, a connection acknowledged, and then we, the client, we reset the connection, as in we closed it off. Usually you would send data or send the third part of a TCP handshake. This is called a TCP handshake, where you send a SYN packet, you get a SYN ACK. Let me show you here. TCP handshake. It's better if you look at it in a diagram. It's you send to the server a SYN, the server sends a SYN ACK, and you send acknowledged, and then you have a connection that's established. Here's a better one. You send a SYN packet, the server responds with a SYN ACK, and then you send an acknowledged packet with your data. Um, but this is not what's going on here. Here we closed off the connection because we got the reply, which meant that we know that this port is now open. And you'll see the same, for example, for what other port did we found that port, let's say, port 22 is open, SSH. So we're gonna go back to Wireshark. We're gonna look at our packets and well, let's say IP dot port. Can I just do IP dot? No, TCP dot port is equal to 22. We're only looking for SSH connections. And see, here's what happened. This is actually me sending. This is from the initial port scan I did with my router. I sent a SYN, and the router responded with a reset. Right? Reset. It didn't respond as a reset and an acknowledged. But look what happened. See these two at the top is me talking to my router. These two is me talking with my router, and then these three down here is me talking with scanme.nmap.org. So look at the top. Port 22 is closed on my router. So I sent the send packet, and the router responded with a reset and acknowledged. But however, when I sent to scanme.nmap.org, I received a SYN ACK, not a reset ACK, a SYN ACK, which the server is telling me that okay, which tells me that this port is alive. Then I'm the one who responded with a reset so that I could close off the connection. That just explains. I took way too much time to explain that, by the way, but at least now you guys have a good idea of what the TCP SYN scan does, and that is the most commonly used way of scanning. Now, okay, here's what goes on. The ST, if I use ST, a different kind of scan technique, let's say like this, which uses connect, where it manually connects to every single port and sees if it works. It doesn't send a SYN packet. It literally tries to initiate a fully blown connection with every port, which is significantly slower. Another one is sending ACK packets instead of SYN packets, which if the server responds with a reset packet saying like, okay, I don't know why you're sending me an acknowledged packet. You didn't start a connection with me. You're just sending the ACK packet. If you're trying to understand what sending an ACK packet means, it's if we go back to the TCP handshake. You'll look here and you will see that we are supposed to send a SYN packet first. Now, what's going on here is that we're ignoring the first two parts and we're directly sending an ACK packet, and we're directly just sending an ACK packet with some random data, and the server will be confused because we didn't send the rest of the TCP. We didn't start as a handshake. Where is the initial SYN packet? The server never got it. So what's going to happen is that the server will respond with a reset. The server should respond with a reset connection, or it should respond with something else. If what do you call it? If the port is closed. See, we tried using the connect scan and it didn't work. It said all scanned ports are filtered. However, we all know that's not true. So the best way to scan is using the SYN scan. It's also nicknamed the stealth scan. I'm not going to explain the rest because you don't really need to know them. Just use the SYN scan. UDP, because UDP is different. If you want to scan UDP ports, you have to explicitly define that you want to scan UDP. You can't scan TCP and UDP both at the same time. It will give me an error. No, sorry. What the hell? It didn't give me an error. I think they added that you could scan both at the same time. Really? Okay. But if you want to scan UDP ports, you have to write SU. It's better for me to add the verbose just so we can. UDP usually takes a long time. I'll tell you that. It usually takes a long time. Because of how UDP works. See, 4 minutes just so I could scan 1,000 ports. The SN is the TCP null, fin, and XMS scans. Now, I'm going to explain the TCP fin, the SF scan. If you see here, it was right here a second ago. This is how a fin scan looks like. You send a fin packet, you receive an ACK and a fin, and then you send an ACK. Now, that's not really, it's just all of these are different types of scans. You don't really need to know them now. All these are different types of scans. We don't really need them. Well, let's look at the port specification. You could specify certain port ranges. So if you want to nmap scanme.nmap.org, and you only want to scan ports. Why do I keep forgetting to put the arguments before the target? You only want to scan from port 1 to 80. All the ports between 1 and 80. You don't care about any other port, and you're going to get the ports between 1 and 80. You could also specify certain ports like 1, 2, 3, 21, 22, 80, 445, and that should scan. And you're going to see that number 1, number 2, and number 3 are closed. Number 21 is closed, and port number 22 and 80 are open, and 445 is closed. That's it. That's literally how you can specify. And if you want, like, you could do TCP and port. You could do TCP and port. TCP and UDP. So if you do, I want to scan UDP 53, I want to test if there's a DNS server on this, and I want to test TCP port 22. It should send that. It didn't give me the scan for port. What if I say just U53? 0 ports scanned. What the hell? That's odd. I think you need to specify SU. Oh, I didn't have root privileges. I am so sorry. Okay, sudo. Think now it should work. U port 53 and then TCP port 22. It should scan. Okay, and it told me that TCP port is open. Host is up. 0 ports scanned. I don't know why it's refusing to scan UDP on port 443. Oh, okay, there we go. Closed. Okay, so you have to explicitly specify the SU, which means you can't scan. What do you call it? You can't scan TCP and UDP at the same time. You could exclude some certain ports or port ranges, which means that, okay, if I want to scan all the ports from 1 to 100, let's say, let me make this TCP, but I don't want to scan port 80. So you're going to go exclude ports and then port 80. It should scan unrecognized. Oh, okay, I forgot the D here. It should scan all the ports from 1 to 100 except port 80. As you can see, we didn't get not shown 98 closed ports. It didn't scan port 80. Now you could also say, okay, I don't want to scan from 1 to don't scan from 1 to 50. Don't scan from 1 to 50. However, that is weird because you could just do whatever. You could just exclude certain ports. Okay. Also, if you want to scan every single port, because usually what Nmap does is it scans 1,000 popular ports, the top 1,000 ports. If you want to scan every single port, all the 65,535 ports, you will do this. And I already discussed this. However, it will take a serious amount of time for you to scan. So yeah. Fast mode, scan fewer ports than the default scan, even less ports if you want something that's fast. So if we do fast, we don't have verbosity enabled. I like to have verbosity enabled, and so it's only scanning 100 ports only, from 1,000 to 100 ports, which is the top 100 ports. That's it. Remember how in the Wireshark we saw that Nmap was randomly scanning? You could tell it to scan consecutively in order, don't randomize, and that is it. That's all you need to know in this part. Service version detection. So you could tell it, okay, remember how we said let's focus on port 80. So Nmap tells us here that port 80 is open and it's HTTP. But what if we want to know exactly this version that is running on the other side? You'll do SV, and it's going to take longer, obviously, but it's going to take longer. And I explained this in my previous exercise. I'm just going over it in detail. And it's going to tell us, okay, it's Apache 2.4.7. Now you could do version intensity. So how intense do you want it to? How intense do you want it to be when scanning versions? From 0 light to 9, all probes. So I could literally just send. I could do version all, which is going to be very, very intense, and it's going to try every single service probe that Nmap has, which are a lot, by the way. It's going to take much longer. And that's it. It's the same. It's the same thing because it's literally the same thing because we don't really need to worry about anything. Uh, it's just well, this is usually for ports that never gave you an exact version. So if do we have something up here that didn't give us an exact version? Uh, do we have an open port? Let's say no. Okay, these are filtered. We can't really find out. But okay, that's basically what SV does. Lets you know the service behind a certain port. Script scan. We already went through this. Enable OS detection, and then there's OS scan guess OS more aggressively. I already went over this. If you add O, then we're gonna go OS scan guess. And it is going to aggressively try to guess the OS running on this machine. However, the problem is it's going to scan all the ports. There you go. We got aggressive OS scans, Linux 3.3 or 4.2, and it is 99% sure. That's just how it goes. Timing and performance. So as I said, from T0 to 5 is the timing template. So 0 is the slowest, 5 is the fastest. Uh, I don't know what this does. I don't know what this does. I don't know what this does. Max retries. So as I said, you already know that Nmap retries ports. Now, if you don't want it to do that, you could specify Nmap, and this is really good when you're scanning a the full port scan, like all these ports. You could go max retry 0. Max max retry 0. So if a port doesn't respond the first time, don't ever try to don't retry it. Oh, we should go PN. And you should see a bunch of them right now. It should output. See, giving up on port because retransmission cap hit 0. So it's gonna tell you when okay it gives up on a port because it didn't answer the first time. Uh, that is literally what it does. It just helps your scans be faster. I'm hoping we're not going off topic here, but as I missed yesterday's lesson, so that is why today's lesson is going to be a bit long. As I said, if you guys have any questions, hit me up in the Discord chat or hit me up in this chat right here. Ask. I don't want to. I feel like I'm going nowhere with this video. To be honest, it's already been an hour and a half. I think we're just gonna finish up Nmap today, and then by tomorrow I should stop streaming these and I should pre-record them, which will give me a bigger advantage and help me edit stuff better. So pretty much, yeah. I'll see if I could set up a vulnerable web server that does not require a login, such as the VWA, so that we could properly test. So we could properly test some tools, these tools, how do they work, and what is the expected output from one of them. Or if I manage to land myself a contract for vulnerability scanning, if any of you guys own a website and you want me to vuln scan it, that would be really cool because I could also use it as a live example for people. So that's it. So as you can see, it took a while, but here are all the ports, and it says not shown 64K or almost 65K closed ports, and 600 filtered. This is the minimum rate. Send packets no more than number per second, and send packets no faster than. This is for rates, and that's pretty much it. Firewall evasion and spoofing. Fragment packets. This splits one packet into multiple pieces, so that it could go. Sometimes it could fool a firewall, because the firewall has to assemble the packets. And for huge companies that they have a lot of traffic, they usually disable this option because they don't want to put so much load on their firewall for assembling packets and reading them, and assembling packets and reading them. So yeah. Cloak a scan with decoys. So you could act as if a bunch of IP addresses are scanning a certain IP. So if I'm scanning scanme.nmap, and I wanna make it think that it's being scanned by Google, I could do 8.8.8.8, and now as it scans scanme.nmap.org, it will set the receiving IP to be 8.8.8.8, and it will think that it's being scanned by Google. Usually you want to include your actual IP as one of the decoys. It just helps it helps so that the packets actually reach you back. You know. Uh, Spoof source address is the same thing. Use specified interface. If you have a Wi-Fi interface or an Ethernet interface and you want to use a specific one, this is how you use it with E. Source port, because the packets have to leave your machine from a specific source port. So I'm gonna fire up Wireshark again. Let me see. I'm gonna fire up a new terminal. Go sudo Wireshark, just so you guys could see what exactly is going on. And we're gonna go to my Wi-Fi. We're gonna go TCP.port is equal to 22. And as I said, we're gonna scan, and we're gonna set we're gonna scan normally, and we're gonna say port 22 scanme.nmap.org. We're gonna scan it. We're gonna go back to our Wireshark. Okay, we got the classic synac, and as you can see, this first number here, this 58244, is the port as which the packet leaves my machine. If I run the same nmap command again, it should be a completely different random number. As you can see, 56400. Now, if I want to specify this number, maybe, I don't know why, but if you I think there's a reason for it. I don't know it, but if you want to specify, you could say G is equal to 666. Why not? And if I go to Wireshark, you will see that the packet left our machine from port 666. That's just a visual example for you guys to get a good idea. Proxies, this relay connections using HTTP or SOCKS proxies. This is good if you want to scan through Tor. Append custom payloads in hex. Append custom ASCII string to send packets. For example, you could do data string. Haha, you fools. Or you could do you shall not pass, and it will append this to every single packet. Now, and we got filtered because our packets are kind of are messed up. But if we go to the latest ones, you see at the very end it says you shall not pass. At the very end of the packet, it says you shall not pass. However, as you can see, it did break it. It did break our port scan. I don't know why you do this, but you can. Um, let's see. You shall not. That's it. And data length. Append random data to send packets. You could make. You could make. So you could do data. If you want to make it look like legit packets, you could just add a bunch of data, like 200 bytes of data to your packet. Again, as I said, it messes around with your port scan, but see, all this is just randomized data. All this at the end. Wireshark even highlights it for you. All this part is just random data that has been added by Nmap. Um, Spoof MAC address, you could spoof your MAC address. This is especially good if you're scanning on a local network. And a bad sum is sends packets with a bogus TCP checksum. Usually firewalls will drop any packets with a bad checksum. So yeah. This is for output. You could output in normal, output in XML, output in script kiddie output, which is just a joke by Nmap, and output in greppable format. And then you give it a file and it will output to it. Or output in three major formats at once, and then increase debugging level or increase verbosity level. The more V's you add, the double V is for greater effect. So if you bring, let's say, if we bring the same port scan over here, and then we add double V, it should be way more verbose. As you can see, all this data that we got up there. And if I want to output the scan to a file so that maybe I could read it with another external program later on, I could do OA and call it, I don't know, test scan, and it should create three new files. As you can see, testscan.gnmap, testscan.nmap, and testscan.xml. And I will remove these three. Yes, yes, yes. And let's actually remove this too. What else? Debugging, reason, display a reason a port is shown in a particular state. So if you want to know why a port is filtered or why a port is closed, you could do, you could add reason, and it says, it will tell you that synac with a time to live of 56, it received a synac packet. Only show open ports, don't show filtered. This is good if you want to simmer down the results of a port scan. Packet trace, show all packets sent and received. Usually, that's going to be a lot. Print host interfaces and routes. This is for debugging. Append to rather than clobber specific output files. I don't know. Resume an aborted scan. This is usually if you have a huge scan and you closed it halfway and you want to resume that scan. I have no idea what this is. Style sheet, XSL style sheet to transform XML into HTML. This is to transform your XML scans into HTML, and I don't think you guys are going to be using these three, so don't worry about them. And these are the Miss Angeles or Miss, I don't know how to say this word. 6 for enable IPv6 scanning. If we wanted to scan using IPv6, I could add the 6. We're still going to use port 22, and we're going to go with 6. Whoa, what's going on? It's kind of like dying. Do you need an IPv6 zone? Here you go. It gave us filtered reason, no response. I don't know, but here's the IPv6 address of scanme.nmap.org. Assume that the user is fully privileged. Assume that the user lacks raw socket privileges. Send Ethernet frames or IP packets. Don't worry about these. Specify custom nmap data file. Don't worry about that either. A is when you want to. A is like aggressive. If you want to do if you want to do a lot of if you want to do a lot of if you want to get a lot of information. So if I add a, it's gonna do a. If I add a, it's as if I did sv sc with a couple of scripts, and if as if I did trace all these three options, but instead and o also, but instead you just do a, and it's gonna do all that for you. It's gonna take a while, but that is it. And v to print the version number, and H is for, I don't know. Uh, oh, this help page. That's it. That's literally it. And I don't really want to wait for this scan to finish because, as you can see, it's 2 seconds remaining. 0 seconds remaining. Okay, it's just going. And since you can, it used a script called SSH host key, and we got the host key for this SSH server. We got the version. We got the OS. It's Linux 3.x or 4.x, Linux version 3 or 4, and we got the trace route also. So yeah, that's pretty much all of Nmap, guys. Uh, and that is a full tutorial on Nmap. Now I said that we want to finish Recon by today. So how exactly would you go about a Recon for a company? Now you have a tool called, I'm just trying to quit Wireshark. Where's the terminal running it? Right there we go. There is a tool called GitRob that will search GitHub for sensitive content that may have been uploaded by an organization, or as you could say, or as I said, use Google to your advantage. You could scan, you could do Google dorking, you could use Shodan. Shodan is really cool. Uh, Shodan.io. Uh, Usually you need to log in to use filters, I think. If I use org Trump, yeah, please log in to use. So search for an organization, the Trump organization, or the NSA or the FBI. Search for servers that are owned by the FBI, whatever, whatever, blah blah blah. Uh, what else? Uh, oh, reverse DNS scans is also cool. Reverse DNS scan. Reverse DNS lookup. This is usually if you want to find out if there are multiple websites that live on the same IP. For example, are there any other websites on Trump? Are there any other websites that have the same IP as Trump.com? And you'll say that. Uh, oh, okay. Usually you need a Cloudflare site would have a lot of examples. Hmm. Whoa. These are all the IPs that are associated with Cloudflare.com, as you could see. It also includes subdomains, but usually reverse DNS is no wait. Reverse DNS is what turns. Uh, yeah. Uh, oh, reverse DNS. Sorry. Reverse DNS is an IP to an address, an IP to an address. So if you want to check that there are multiple domains associated with the same IP address, like let's ping, let's ping donaldjtrump.com, and you'll get an IP like such as this. And let's say, okay, check reverse DNS. Are there any? And you'll tell you no. Uh, that is it. Let's go for something else like this. Reverse DNS, enter an IP or IP subnet. We're going to enter this. Oh, you're going to scan. It should find nothing. No PTR record. Reverse DNS scan is usually cool if you want to check if there are multiple servers that resolve to the same IP. So if you have a target, you should ping that target, get their IP, and do a reverse DNS scan. You could do it from the command line using PTR. Like I said, dig PTR. Let's say google.com. Wait, no. Dig PTR. Let's do cloudflare.com, and wow, we actually got nothing back. That's odd. Dig PTR, twitter.com. Nothing. Okay, whatever. So reverse DNS scans, just do them online. They usually help. Uh, no one has any questions whatsoever at all. Like literally no questions, any questions, anything at all. Uh, So we finished with web recon. What's next is a proper. I think the next session should be today's Thursday. I'm unavailable on Friday and Saturday. Sunday is when I will be back. and hopefully over the week, because Friday and Saturday is a weekend for me because I live in the UAE. So hopefully over the weekend I won't be able to live stream, but maybe I can privately record something that's proper, a proper example of web scanning, and I can upload it to YouTube. Um, let's see, on Sunday I should be back, and I think we will officially. I think on Sunday, I think we're not done with Recon. Sorry about that, but I think on Sunday I will come back and we will do a scan on we will do a user recon. Now that's not really pen testing, but it's cool to learn how would you go about and find information about a person online. You will get into some pretty cool Twitter tools, some Facebook tools, some social network tools, which could be also, by the way, could also be used against the company. You could test if a company has a Twitter account, and then you could use the same techniques that I'm going to teach you. For organizational Twitter accounts. We're also going to be looking at into leaked databases and all that kind of stuff on Sunday. What else are we going to be looking at? And I think after that we will officially be done with Recon, and we can finally. I think no wait, Metasploit has a few Recon modules. I'm going to go in there and show you guys that as well, and on Sunday, and then hopefully. But after Sunday, we'll go with Monday, which will be our very first introduction to web exploitation. We're going to start with web exploitation, where I'm going to explain the top 10 web vulnerabilities, what to expect, like how to parse results that you got from a recon scan and stuff like that. Please note that I'm sorry that it's not exactly ordered and we don't really have a set schedule. It's just that this information I just speak out whenever it comes to mind. I can't really remember a set of certain information. Sorry about that, but um, another thing to notice that CMSs like WordPress, I think I'm just going to show you this really quickly. And another note to have, we're going to go into my hacking folder. I have something called CMS map. Now CMSs are CMS map are pretty much WordPress is a CMS. Drupal is a CMS and Joomla is a CMS. Those are examples of CMS systems. Now CMS is like I said, they sometimes they come with plugins, and those plugins have vulnerabilities, especially WordPress. WordPress plugins are one of the biggest security nightmares for people because most of the times even the themes themselves can have vulnerabilities. And and so if you find out that a site is running a CMS, you'll get a much better chance rather than because the person who owns the site wrote no source code. So you can't so you could go ahead and use the traditional tools against the CMS website, but what's better for you if you know a site is using a CMS, go look for a CMS tool that will look up the plugins that this site is using and see if any of them are vulnerable and see if any of the themes that this site is using are vulnerable. However, that is Blackbox, so I can't really show you an example right now. Uh, you guys should try this tool at home, the CMS map. As I said, just a quick example of all the tools you could get. If you search web vuln scanner and then you type in GitHub, you will literally get, okay, we have web pooner, we have web based source code vulnerability scanner, we have python scan, venom scanner, we have wapiti, CMS map, vuls, Nikto, XSSPy, and you could keep going on and on. Even I think even if you go all the way to like the fifth page, you should still be getting vulnerability scanners, Sparta vulnerability scanner, uh, SQL map for SQL injection, Onion scan for scan investigating the deep web. Literally Google. GitHub is an amazing place where a lot of open source are developed. I love open source tools because it's great for people to put ideas that they have out there, and open source, especially on GitHub, has a nice community. Don't hesitate that if you have a feature you'd like to suggest in a certain tool, go ahead, walk up on GitHub, put a new issue, and ask for additions, and hopefully, who knows, maybe you'll be the reason why a specific tool will get a really nice update with a very specific feature. Uh, Sorry about the sounds. And so I think that pretty much concludes this lesson for today. So I'm sorry I didn't have a. I'm sorry I didn't have a. I'm sorry I was like, a bit in the beginning. I was very very unorganized, and it was pretty much my stream was all over the place. The DVWA, at least I introduced you guys to that. You could go read up on that so you could be ready for our web exploitation class on Monday. And I'm sorry about the, I didn't have any time. I couldn't show you a proper web scanning, web vulnerability, web vulnerability scanning tool in action. However, I will show you this pretty cool tool called Sniper. It is a automated Recon scanner. It is really cool. I think I showed it in my previous videos. It's pretty cool. Pretty cool. It even generates a nice report at the end. So pretty sure be sure to check that out. Um, I think that is it. There are no assignments for today. I would usually give an assignment, but I mean I didn't really teach anything new today, and I can't really give assignments and black box assessments because you know who are you gonna attack? Uh, I think that's pretty much it. I'm gonna go now and I'm gonna end the stream. Thank you guys for watching. Thanks for tuning in. This has been the longest lesson I did. We're almost hit the 2 hour mark. Uh, if you guys have any specific things you guys want to learn, please do help inform me. Hit me up on Discord. Hit me up. I think most of you guys who are watching this should know my Discord. Or just leave a comment on the video once it gets uploaded. Uh, that's it. I think that's it for today. So I'm gonna go now, and I'm gonna remove my phone number and email, and I'm gonna crop out all the beginning. I'm gonna crop out the beginning part because it was kind of retarded. And that's it, guys. Thanks for watching, and that concludes our third lesson in the pen testing bootcamp, which is black box recon in both web and servers. We haven't touched on user recon yet. Uh, we'll get to that on Sunday. That will be our next lesson, and then after that, we'll be done with recon, and we can move on to exploitation. And that's it, guys. I'll see you guys in the next lesson.